Sorry for interruption. So we're looking for the absolute maximum and the absolute minimum. So let's look for the maximum first. See this arrow? This arrow means that y is continuing to go up forever. So it will never reach a maximum value. It'll go to infinity. And infinity can't be the maximum value. Absolute maximum. So because there's an arrow, there is no absolute maximum because of the arrow. The absolute minimum of, okay, where's the lowest y? Right here, when y is 0. Of 0 occurs at x equals what? X equals 4. So that's the absolute minimum. That's the lowest point on the graph. Over here, so there's two arrows going down, which means they're going to continue down to negative infinity. So there is no absolute minimum. And then the maximum, it's here and here, it's a tie, right? They're both at 2. So it's a tie. The absolute max of 2, because that's the y value, occurs at both x equals 0, that's right here, and x equals 2. That's how you write it. Is there a maximum? Well, there's an open circle, it's a hole. Because there's a hole, there is no absolute maximum. It's an open circle. If it was closed, then the maximum would be 5 at x equals 0. And then the minimum value is right here. It's not an arrow. So what's the y value? -4, and it occurs at x equals 3. The absolute minimum occurs, the minimum -4 occurs at x equals 3. That's how we write it. And then this one, there's a dot right here, so that's the minimum. And there's an arrow right here, so there's no absolute maximum because it goes up forever. There's no absolute maximum because of the arrow, and the absolute minimum of, what's that y value? 0 occurs at x equals 0. It occurs at x equals 0. the extreme value theorem. If f of x is a continuous function, and a continuous function has no gaps, no holes, can be traced without lifting pencil from paper. You can draw the whole graph without lifting your pencil from the paper because there's no holes and no gaps. If it's continuous and whose domain is a closed interval between A and B, then f has an absolute maximum and an absolute minimum on the interval between A and B. They have endpoints, A and B. It doesn't go to infinity, so there will be an absolute maximum and an absolute minimum. With the extreme value theorem, the absolute maximum or minimum can be found by selecting the largest or smallest value of f from the following list. The value of any local maxima and local minima of f in between A and B. It's the value of f. The value of f at each endpoint. It can be an endpoint. The value of f on any interval in AB in which f of x is constant. If it's constant, it can be a maximum or a minimum. If it's constant. Notice that the third graph, it says fourth, but when we look at the graph right here, this third graph has the hole right there. Notice that the third graph of examples of is continuous on the closed interval -2 to 3. Is that what it says is continuous on the closed interval from -2 to 3. Therefore, the extreme value theorem guarantees that x has an absolute maximum and minimum on between -2 and 3. Is this what you found when you completed the problem? So we're going to write no, and we're going to say it's not continuous. There is a hole. If there's a hole, then all bets are off, or a gap. So your homework is going to be number 13, and I'll put it on Canvas, and it won't be due until Wednesday because there's no school on Monday and you're not getting more homework on Monday, so it won't be due till Wednesday. So it'll be homework number 13. I'll put it on Canvas. Okay, thanks.